All right, hello everyone. October 27th. All right. It's a lot of things today. All right, let's get into it. Count vowels permutation. Given an integer, your task is to count how many strings of length n can be formed under the following rules. Each character is a lowercase. It's about how many strings of length n can be formed under the following rules. Each character is a lowercase vowel. Each vowel A may only be followed by another E. By an E. E may only be followed by A and I. I may not be followed by another I. O may only be followed by an I or U. U may only be followed by an A. I don't remember the solution, but I think it's one of the easy ones. So A may only be followed by an E. It's a graph, right? A will be followed by E. E may only be followed by A. Directed graph. E and I. Okay. I may not be followed by another I. So I can follow anything, but cannot a self. O may only be followed by O can only be followed by I or U. U may only be followed by an A. So we have A, E, I. I can follow anything except for itself. So I can follow E. Oh, I can follow A as well. Do it again. A, E, I, right? So this is this. E can follow, I can follow, E can follow I, right? I can also do A. And I, O, U. So we have O, right? O. So I can follow, I can follow O and I can go to O, right? And O can only follow U. And U may only be followed by an A. So that's it. I is 1, 2, 3. Oh, I can follow, you can follow I as well. Right? I can go to E, A, U, O. So it's a rather complex graph. And we're asking, given integer n, so we have n, right? Equal to 5. Let's try 3. Let's try 2. Okay, so we have 2. And say what are the different ways. So basically, we're trying to see, starting from a position, right? Like we start from A. How many can we make starting from A? I mean, A, the next one is E. That's it, right? A can only follow by E. So if we start from A, then we're asking how many we can do from E, right? So basically, it's going to be a dp of starting. I mean, we can say A, E, I, O, U, right? We can do that. So we have dpij. Okay, dpij. And it's we starting from I. Oh, starting from. If you're gonna do like this, that's not starting from, right? It's end of starting from. Then we can go right to left. Right? We can go right to. We can always go right to left, which is just fine. So we say starting. Starting from vowel I. Right, starting from vowel I. with starting from vowel I with length j. How many? Right? What the hell happened? Why you always turn to this? So the length. Let's do 5. Just give it a shot. See if we can get 5 out. So 5, it's gonna be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, right? A-E-I-O-U. A-E-I-O-U. And length is 5. So hold on. Yeah, let me rewrite this. 0, 1, 2, 3, 4. A-E-I-O-U. And this has to be 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4, 5. Because length is 5. Our length is 0. How many different ways to get 0? That should be 1, right? And we deal with the zeros later. But anyway, so we're starting from A. If it is 1, that's only 1. We start from E. That's just, these are all 1. All right, we start from here and we have only length is 1. So now we start from A, length is 2. So we look for A, right, length is 2. You know what? Maybe it'll be easier. Because length is 2, basically, we say, what's the next one with length? Right? Length is 2. So we find the next possible is E. Right? So we find my next possible is E. And we have E1, so that's only 1. So this would be 1. Now we go to E. What's E's next? E next. Yeah, this is not the right way to do. Hold on, let me redo this entire thing. Let me redo this entire thing. Yeah, it is a graph, but it's not the best way. So we have A, E, okay? E may only be followed by A or I. I may not be followed by another I, so I can say A-E-I-O-U. A-E-I-O may only be followed by I or U. And then U may only be followed by A. So this is our relationship. So we start from A, is going to be E, right? Now we start from E, can be an A, and A I already did. A is 1. Or I can be an I is 1, so this will be 2. Now we start from I, can be A, I, also we add them together, so that will be 4, right? Starting from I, we have 4. And starting from O, we have 2. And starting from U, we have 1. So we add these together. So 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 3 is 10, right? So now it's 3. So we start from A, again, we E. So when you say start from E, need to have 2, right? So that's what give you 2. Now start from E is going to be A or I. So we add these. So that would be 5. Oh, that's not, no, that is 5, right? Because you add these two together. You add these two together. Yeah, you say start from E, then you need to say how many A's do we have, how many I's do we have. So that's 5. And then start from I, then you add these together. So 1 plus 2 plus 2 plus 1, it's 6. Start from 0, it's IU, that's 5. And start from A, not U, that's just A, so that's 1. Okay, now I do it again. A is going to be equal to E, And then a plus I. That was not hard, all right? And then this is, yeah, that's just 4. You can just add. That's 7, 8, 13. O is IU, 7. U shall equal to A. That's 2. Okay. Moment of truth. So A equal to E. E equal to A plus I. That's 18. This will equal to everybody together. That's 22. And O will equal to I plus U, which is 15. And U will equal to A, which is 5. So we add these together. What's this? 20, 48, 42, 60, 68. Okay. I think that's how we're gonna do it. And of course, we are not doing the whole thing. We're gonna just do a single row. Okay. So it'd be 0, 1, 2, 3, 4, and then we start with 1. Right? We start with 1. So if n equal to 1, that's gonna be 5. Right? We just add them together. Okay. That shouldn't be too hard. Unless there's some trick that I didn't realize. That will be unfortunate. Oh. So res has to be an integer. Okay, so int dp shall equal to new int 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. And yeah. And then for int I equal to 1. Now we done 1, so 2i smaller equal to n I plus plus. So for each one, we're gonna get a new, so int temp new int 5. Right, so temp 0 shall equal to dp dp1. Right, so we call this as a e. Okay, and temp 1 shall equal to dp 0 plus dp 2. Right, this is e, a or I. Oh, we need a mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So mod. Mod. You know what? It's too long. Just in case. It's long. Dear me. Okay. And temp 2 is I is gonna be dp 0. Oh. Huh. Hold a second. AI O. Right? O is what? O, I, and U. So dp 0, 1, 2 plus dp 0, 1, 2, 3, 4 U. Okay? Mod. O. O followed by I or U. And then temp 4 shall equal to temp dp 0. dp 1, 0. You don't need mod this. Okay, so this is U followed by A. Now temp 2 is going to be let's say temp 1 plus temp 3 minus dp2. Now temp 1, temp. So that's 0 to 4. I'm gonna add 1, 3. Yeah, you might as well just put them together. Dude, what's your problem? Seriously, what's your problem? No 2. 0, 1, 3, 4. I is A, E, O, U. Then dp equals temp. And once we're done, we say long rest equal to 0 for d long d of dp. We do rest equal to rest plus d mod, and return int rest. Does that work? Two, 3, 4, 5, 6, 7, 8, 9, 10, 100, 100, 1,000, 10,000, 20,000. Yeah, I think there's nothing more to this, right? Yep, that's it. That's the previous solution. How about this one? Oh, that's the one. Matrix power. Oh, matrix power. Matrix power. I think that's the one, but yeah. I'm okay with it. I don't want to do matrix power. The trivial DP solution is not difficult, but the magic of using matrix power to compute the DP process is not easy. However, I have no intention to implement DP power in Java. Come on. Nor do I have the Ghana to write DP power, to write no, not DP power, matrix power, right? To write the matrix power solution in Python again. I think you just to know that you can use matrix power to do this. I haven't touched the matrix for a very, very long time. 5n. Yeah, just do 5n. Oh, they call it state machine. Wow. Can you make it even longer? I think it's not long enough, man. Oh God. The matrix power is hard. Anyway, that'll be it. I don't want to keep doing this. All right, you want to try this one again? Yeah, why not? So I already know how to solve this. So this is to find a mountain array, right? So, if I want to solve it, I have to solve it here. So to find the mountain array, not find the mountain array, given a value, to find if it's in the mountain array, to minimum index such that this is equal to target. If such an index does not exist, return -1. You cannot access the mountain array directly. You may only access the mountain array through interface.get. Returns the element of array at k, 0 indexed, and the length. So I remember the idea is to first find out where the peak is, right? So we need to find out the peak. So we have a mountain array, and then it's, no equal. So we need to find a peak. So we pick the one in the middle, and then we say this is the peak, okay? Then what? We need to check if this is the peak. So we compare the neighboring, right? We compare the neighboring. Now, if we have this, right? If this is what we find, and that's the peak already, right? We're done. If it's this, right? If it go this way, this is the one we find, then it's an increasing edge. So we will find the peak in this range. In fact, not even including this, we're finding this range. Ooh, what's binary search, you know? Yeah, you know. I think I'll use the one that's left I smaller equal to j, right? So I can do that. So I found this. So yeah, we do that, and then we'll find the center, the point, and then we need to write a binary search for the target. Now, if the target is, well, not really, then we just binary search on the left hand side, right? And binary search on the right hand side. That's it. Now the binary search on the left hand side and the right hand side, are they the same? I'm not so sure, but it's left bias, so it'll be easy to deal with. I remember when I was doing this, there was an attempt. I think I write the left bias on this one as well, but it's slightly different, right? Slightly different. Oh, it doesn't matter. Oh, there's no bias. Ah, that's the one. There's no bias. Why? Because it's never gonna be equal, right? It's never gonna be equal. So there are two ways, right? We can use the built-in binary search, so you don't have to write one yourself. Now this is going down, right? So if you want to do a binary search on this, will be slightly awkward. So yeah, we have to write a binary search for this, but it's fine. We can handle the binary search. All right, so let's first find the. So we need to first find. Oh, that's interesting to see if it works. Never tried this before. Does this work? Interface? Interface astronaut cannot have body. Okay, so I don't have a body. Do I need to do this? That is amazing. I've never done this one before. Huh. Okay. So first find the position of the peak. So low equal to 0 and high equal to target. Nah. Mountain dot get, not dot length. -1. Okay. And then while low smaller equal to high. Okay. Int mid equal to low plus high. Divided by 2. Int let's do int mid outside. So it's a mid is this, right? Okay. Now we say there always will be something on the left because there's at least 3, right? At least 3. So it's not possible for them to be all on. So there will be a mid -1. There will always be a mid -1. So we say if, we need to say left, low, high, mid, pre, current, next. Okay. So pre will equal to this dot get mid -1. Current will equal to this dot get mid, and next will equal to mountain array dot get mid +1. Okay. And we say if pre smaller than current and larger than next. then we find it, then we break. Huh. You break. You break. Okay, so we need peak index equal to -1. Okay. So of that, then we say peak index equal to mid and break. Done. Okay. Otherwise, if pre smaller than current and current smaller than next, what do? Well, when that happens, we do it's on the left hand side. So low shall equal to mid plus 1. Else, well, the only possibility is, yeah, there's only one more possibility. Is pre is larger than current, and current is larger than next. So that, it's on the right hand side. So high shall equal to mid minus 1. Now, do we do mid minus 1? Or we do mid minus 2? Right? If you think about it. If we are in the left peak, the left edge, slope, right? If we are on the left slope, and we know they are not going to be that's the mid, right? So we say with a search need to go here. Yeah, only plus 1. Only plus 1. So plus 1, right? And then this will be minus 1, so they will meet in the middle. Now, will they meet in the middle, or will they, that's a good question. Will they meet in the middle, or will they, like, skip? Well, it's either this, right? So if it's this mid, then we go here, right? It'd be plus 1. And we do, and then we minus 1. And then eventually, okay, what if it's this? Like the distance is only 2. What if the distance is only 2? It's okay. What if it's here? Mid is here, so it's no good. So mid plus 1. Yeah, I think this should be fine. Okay, so when we get out, and we say if peak index smaller than 0, then peak index equal to low. Doesn't matter, because when I get out, that will be the 1. Okay, so we have found the peak. Now binary search the left edge first. Okay. Low equal to 0. High equal to peak index. Okay. While low smaller than high, I can do that. Mid equal to low plus high divided by 2. And current equal to this dot get mid. If we might call someone multiple times. No. We just compare the current. If target, right, is, oh, you might consider that. You might. Because if you find it immediately, you can just return, right? Because the other one we have to do a lot more. So to reduce, I might, otherwise it's left bias, right? If it's left bias, so we don't move the right. Yeah, it's left bias. So we don't move the right. But I want to do this way. So if target is equal to current, boom, return. That's the answer, mid, right? If target is smaller than current, current here, target is smaller than current, then we will high shall equal to mid, but I can do mid minus 1, else low equal to mid plus 1, because I have it equal, so I can shrink on both sides, right? I can shrink on both sides. Yeah, if the target is larger than, then low will be plus 1. So blah blah blah. If I didn't find out, then we say binary search the right edge. Now right edge is decreasing. So the binary search rule is a bit different. Okay, so again, low will equal to, I mean, we can, right? We can just swap the idea. So low equal to, mountain array dot length minus 1, all right? High will equal to, and if I haven't found it, so that's gonna be peak plus 1, right? And while low is larger, you go to high. Mid equal, doesn't matter. I don't really care about left bias or right bias. And we actually can copy and paste the entire thing. The only thing different is the initializing and this part. If target is, this might be different, hold on. If target is smaller than current, so low and high, right? So low and high. So high equal to mid plus 1. Nah, I don't like it. I do not like it. I'd rather go this. It's easier for me to visualize the whole thing. Okay, and this will still be low, smaller, equal to high. Okay, and now I say, if target is smaller than current, so it's on the right hand side, so it should be low equal to mid plus 1, right? And this will be high equal to mid minus 1. And again, minus 1. All right, let's do this number 12. Let's try these. All right, I think we're good. Ugh. I thought it's not gonna happen. Mayan. So, I need to do something. Mid. Why would this happen? I thought it would never happen. 0, 1, 2, 3, 4. So there's 2, 0, 1, 2, right? And this is on the right hand side. So I say high equals mid minus 1. So high is here. High is here. And low, oh yeah, low is here. So mid is this. And then I shall do this is on the left hand side, right? So we have to handle something here. That's fine. I have a way to do that. And so we'll say low equal to mid plus 1. Then it get out. Okay, so yeah, this is just gonna be I can call length anytime I want, right? You know what? Right, mountain array. Let's just do it's gonna be n. Call it once. And here we say mid minus 1 is large equal to 0. Otherwise, minus 1. This is mid plus 1 is smaller than n. Otherwise, 1, 2, 3, 4, 5. Integer the max value. Now that, my friend, shall work. Yep, that works. All right, it's much easier. This is a redo. Oh, sorry, I'm not gonna put this anywhere. So maybe this is just maybe. It depends on if I have a copy of this before. This is 1095. Oh, I don't think so. Yeah, this is a redo following the official solution, where we identify the peak first and then perform and then search, right, for the target on the left and all right edge. Slope, that's the word. Slope, that's not edge. Slope. That was very complicated, I think, the ones that I used the first time. This one's it's cleaner. It's clean and easy to explain. If you take a look at this, it was very complicated. Okay, I don't even know. But this is shorter, much nicer. All right, that will be it. So I can close this finally. All right, I will see you guys tomorrow. Adios.